So in section 6.4, we start doing logarithms, and this might be new to you. A year or so ago, we stopped doing logarithms in intermediate algebra. You may have seen them in a high school class, but you may have not seen them before. So let me talk a little bit about what logarithmic functions are before I jump into the section. So a logarithmic function is a type of function that is used to answer, I'll say, when questions. Specifically, it's used to answer when questions when something is growing exponentially. The Earth's population is growing exponentially, so we can use a logarithm to answer when will the world population be 20 billion. Our national debt is growing exponentially. We could use logarithms to answer when will the national debt be, I don't know, 30 trillion dollars. So when questions are what logarithms are used to answer. When I look at an equation or a function, a logarithmic function, logarithmic functions generally look like this. A logarithmic function usually has the word log, followed by a subscripted number, which is called the base, followed by a number that's on the same level as the word log, which is called the argument. I would read this as the log or the logarithm. Usually we say log instead of logarithm, but they're interchangeable. I could actually spell it. The logarithm base 2 of 8. The two parts of this are the base, which is the subscripted part, which is 2, and the argument, which is the non-subscripted part, which is the 8. Any logarithm asks the question, the base to what power equals the argument. Really? So this log base 2 of 8 is asking the question, the base, which is 2, to what power, which I put as a question mark, equals the argument 8. This log base 2 of 8 is going to give me the number 3, because 2 to the third power is equal to 8. So the log base 2 of 8 is equal to 3. Let me do a few more logarithms before I jump into some rules of logarithms. So I got a quick interruption, so there might be a little hiccup in the video. So we just learned that the log base 2 of 8 is equal to 3. Let me do a few more logarithms just to get you comfortable with them. Let me do the log base 3 of 9. You should know that any logarithm asks the question, the base to what power equals the argument, so that this one, because the base is 3 and the argument is 9, this logarithm asks the question, 3 to what power is 9? If you know the answer to this is 2, then you don't need to use any technology to figure out what that logarithm is equal to. Let me do a few more. Let me do the log base 2 of 16. This is asking the question, the base, which is 2, to the unknown power equals the argument, which is 16. And that's going to be 4. In logarithms, bases aren't always written. If I wrote something like this, find the log of 100, if no base is written, you'd like to think the base is assumed to be 1, but that's not the case. If no base is written, the base is equal to 10. So this problem, the log 100, is the same as the log base 10 of 100, and this is asking the question, 10 to what power equals 100? And if you know the answer to that is 2, then you can just write the answer down without doing any work. If I did something like this, what is the log of 1? Well, I know that this means what is the log base 10 of 1, and this is asking the question, the base 10 to what power equals the argument 1. If you know that anything to the 0 power is 1, you know that this is 0 because 10 to the 0 power is 1. My calculator is really limited. It doesn't have base 2, it doesn't have base 3. In fact, it only has 2 bases. The 2 bases that are on my calculator are base 10 and base e. Let's not worry about base e for a second, and let's worry about just the world of base 10. So on my calculator, I can do each one of the problems that I just did. I figured out the log base 2 of 8, the log base 2 of 3, the log base 2 of 16, the log of 100, and the log of 1. The only problems on this sheet that are easy on my calculator are the last 2 because they're in base 10. My calculator naturally works in base 10. If I see a logarithm that's written in base 10, I don't have to do any thought. I can run to my calculator and press buttons to figure out what it equals to. To figure out what the log of 100 is on my calculator, I find the log button, I type the log button, then I type the number 100, close the parentheses. My calculator tells me that the log of 100 is 2, and that's what I came up just a second ago. Similarly, if I want to find the log of 1, I could just type the log button and type the number 1 and hit equals, and my calculator will tell me the log of 1 is 0. In order to find out one of these logs, because they're not in base 10, I need to use the change of base formula. The change of base formula is a formula that allows me to change from one base to another base. And it is helpful when I go to evaluate logarithms on my calculator. So the change of base formula, or the change of base rule for logarithms, says if you have a logarithm and it's written in some base other than 10, that you can transfer that log to the base of 10 by taking the log of the argument base 10 divided by the log of the base 10. Specifically, it says on my calculator, if I wanted to find the log base 2 of 8, that I could just do the log of 8 base 10 divided by the log of 2 base 10. So to get that the log base 2 of 8 is 3, if I didn't know this, on my calculator I could just go log of 8 divided by log of 2, and my calculator will tell me that that equals to 3. Similarly, if I didn't know that the log base 3 of 9 was 2, this one on my calculator, I can just go the log of 9 divided by the log of 3. Notice I'm putting parentheses in. The reason I'm putting parentheses in is because my calculator throws those parentheses in. So for this one, I can just do log of 9 divided by log of 3, and it's going to tell me that that equal to 2. So the change of base rule is a rule that allows you to evaluate logarithms that are not in base 10 on your calculator. This is actually a baby version of the change of base rule because I don't have to change from base b to base 10 like I did for these. I could change from base b to any other base, but that's really kind of overkill. So almost ready to get into the section. There's one more base that my calculator has pre-programmed, and that's base e. So we should probably talk about base e. My calculator works naturally in base 10. It also works naturally in base e. If I asked you to compute this, find the log base e of 1. Well, this is asking the question, the base e to what power is equal to 1? And if you knew that e to the 0 power was equal to 1, then you know that this answer is 0. There's going to be two ways to get it on my calculator. One way is the clunky way to do it, but on my calculator, I can use the same strategy that I used for the last few problems. So on my calculator, I can do the log of 1 divided by the log of e. And if I did that, it's a little bit hard to do, but I can do that. Log of 1 is not so hard to do. I type the log button, I type the 1 and close the parentheses, and then divided by, and for the log of e, to get the e after I hit the log button, I hit second and the divide key. So there's log of 1 divided by log of e. Log of 1 divided by log of e is going to be equal to 0. So this was one way to work with base e. I said my calculator naturally works with base e, so there has to be a more clever way to do it. And the more clever way to do it is to realize that the statement, the log base e of 1, has the same meaning as the ln of 1. That log base e is what the symbol ln means. So when I see ln, I think log base e. On my calculator, I could have figured out the log base e is equal to 1 just by hitting the ln button and typing 1. And I'll get exactly the same answer as using the change of base rule. So ln and log base e are interchangeable. That's a semi-big deal. So we have a basic, really limited understanding of what logarithms are. Logarithms say the base to what power is the argument. We know a little bit of how to work logarithms on our calculator. Now we are ready to get in the section. And in the section, I'm given some problems that are true statements that don't have logarithms. These are called exponential equations, for lack of a better word, because there's an exponent and there's an equal sign. Exponential meaning exponent, equal sign being equation. The instructions for problems 1 through 7 say write the equation in logarithmic form. If I look at problem 2, if you simplify the left-hand side, it simplifies to 8. It's a true statement with the numbers 2, 3, and 8. What I'm supposed to do in problem number 2 is create a true equation, or a true statement with a log, and the numbers 2, 3, and 8. Using the rule that we're going to introduce, using this rule that says that if b to the y power equals x, then the log base b of x equals to y. This is a statement that, if you read mathematics, tells me that if you have an equation with an exponent, you can create an equation with a log that's still a true statement. My equation in problem 2 doesn't have an exponent, but it doesn't have a logarithm, but it has an exponent. Any equation with an exponent can be transformed into a logarithmic equation. That's what I'm asked to do in problem 2. So in problem 2, which is 2 cubed equal to 8, the b in problem 2 is going to be 2. When I go to rewrite problem 2 with a logarithm, I'm going to write the word log, And then in place of the b, I'm going to put the number 2 subscripted. The x in the equation is the 8 because it's the number to the right of the equal sign. In the logarithm, I need to put the x as the argument. So I'm going to write the log base 2 of 8, putting into this formula 2 for b, 8 for x. The y in this formula is the 3 because it's the exponent, and the y goes to the right of the equal sign. So from this equation, if I could identify the b, the x, and the y, I can place the b as the base, the x as the argument, and the y to the right of the equal sign, and I've produced a true statement with the numbers 2, 3, and 8 that has a logarithm. I claim this is my answer to number 2, and let me show you that it's right. I already know that this is right, but the left-hand side, to do that on my calculator, I do the log of 8 divided by the log of 2. The left-hand side comes out to 3. The right-hand side's already 3, so I've done what I needed to do properly. I've created an equation with a logarithm that has the numbers 2, 3, and 8. That's true. Let me try to sneak in number 1 here. So when I look at problem 1, you're given the equation 3 squared equals to 9. So in your equation, the piece that's in the position of the b is the 3. So the b is the base. It's going to equal to 3. The exponent's the y. The exponent is going to be a 2. The exponent's a 2, so the y is 2. The number to the right of the equal sign in the formula is an x, so the x is going to equal to 3. Y is going to, hold it. The x is going to be equal to 9. Sorry. The x is the number to the right of the equal sign, so the x is going to be equal to 9. I'm going to take these 3 numbers and plug them into the formula, the log base b of x equal to y. So to create an equation that has a logarithm from an equation that has an exponent, you need to identify the 3 pieces, the b, the y, and the x. And now I'm going to shove those 3 pieces into the formula. I'm going to write the word log, and in place of b, I'm going to write a 3. In place of x, I'm going to write a 9. I'm going to leave my equal sign, and in place of y, I'm going to write a 2. I claim that this is the answer to number 1. So I should check this, make sure that the right-hand side and the left-hand side are the same. On the left-hand side, I just do log of 9 divided by log of 3 to figure out what the left-hand side equals to. The left-hand side is 2, the right-hand side is 2. I know I did that properly. So for each of the problems between 1 and 11, we're given an exponential equation. We're asked to create a logarithmic equation. If I move down to do number 4, in number 4, I'm given 2 to the 5th equals 32, and this is supposed to be in the form b to the y equal to x. So in this equation, the b is going to be the base of 2, the y is going to be the exponent of 5, and the x is going to be the number to the right of the equal sign 32. I'm supposed to take those 3 numbers and shove them into the formula log base b of x equals to y. And to do that, first I'm going to write log, and then I'm going to pull out a number for b. The b is going to be the number 2. Then I'm going to put the number for x. The x is going to be the number 32. Then I'm going to put my equal sign, and then I'm going to put the number for y, which is 5. This is supposed to be the answer to number 4. To check to make sure the left-hand side equals the right-hand side, for the left-hand side I do log of 32 divided by log of 2, and it tells me that the left and the right-hand side are the same. So each of the problems between 1 and 11 give me an equation that has an exponent. They want me to change it to an equation that's a true statement that has the same numbers as the original equation, but that has a logarithm. What I'm doing now is using the rule, and it's exactly the way it's intended to be used. The way I'm doing now is really inefficient and not the way I generally do this. So generally, to create a logarithmic equation from an exponential equation, I do a shortcut. The rest of the problems I'm going to do the shortcut way, and I think you'll find it way easier. So let me move on to problem 5. and write the logarithmic form of number 5. So number 5, I'm given the equation 3 to the negative 1 equals 1/3. The shortcut way to do this and this is the method that you'll use 100% of the time. The first thing I'm going to do is I'm going to write the word log on the left side. So I'm going to write a log followed by an equals. For a logarithm, I need a subscripted part and the argument. The base of the exponent becomes the subscripted base. So in my logarithm, the subscripted part's going to be the base of the exponent, which is the 3. And now I'm going to switch sides for the next two items. The negative 1/3 is now going to move to the right side of the equation. And on the right side of the equation, the number is written on the same level as the logarithm. And I'm going to take the 1/3 that's on the right-hand side and move it to the left-hand side. When I move it to the left-hand side, it becomes part of the logarithm. The part of the logarithm that I have in is the base. It needs to become the argument. A logarithm has two parts. It has a base and an argument. I claim that this is the answer for number 5. I don't instinctively, when I work with logarithms, use parentheses. My calculator needs the parentheses. So let me go ahead and check this on my calculator to make sure my answer is right. On my calculator, to make sure that this is right, calculator, I'm going to enter the log of 1 divided by 3 divided by the log of 3. Log of the argument divided by the log of the base. So let me try this real quickly, doing the log of 1 divided by 3 divided by the log of 3. Should equal negative 1 if my answer is correct. When I hit enter, it gives me that negative 1, so I know my answer is correct. If I do the same thing for problem 6, problem 6 gives me an exponential equation, wants me to write the logarithmic form. To write the logarithmic form, I start off writing a log and an equal sign. Those are constants, and now I need to fix the three numbers into the right places. Real easy to do. The 4 becomes the base, and these two numbers switch sides. So when I go to do my logarithm, the 4 is going to be the base, the 1/16 is going to switch to the left side, the negative 2 is going to switch to the right side. Doesn't matter which you do first, so I'm going to switch the negative 2 from the left side to the right side, the 1/16 from the right side to the left side. These are on the same level as the logarithm. The only thing that's subscripted is the base. This should be my answer to problem 6. My calculator needs a parentheses. Let me check this on my calculator real quickly. To do the left side on my calculator, I do the log of 1 divided by 16 divided by the log of 4. When I hit enter, I better get negative 2 because that's the answer, and I do just fine. Just a few more problems, and then maybe we'll do a part 2 to this video. So for 7, 8, 9, 10, and 11, we will use the same strategy. We will take the problem and write it in its logarithmic form. So to do problem 8, to write this in its logarithmic form, I'm going to write the word log followed by an equal sign. The e needs to be the base because it's the base of the exponent. So the e is going to be the base, and I'm going to switch. I'm going to move the 0 and the 1 to the opposite sides. The 0, when I move it to the right side, is going to be on the same level and not subscripted or exponent. And the 1 is going to move to the left side and become the argument. This is an okay answer for question 8. A better answer, because ln is shorthand for log base e, would be the ln of 1 equal to 0. They're both okay. I could check both on my calculator. To do the top version on my calculator, I do log of second divide for e divided by, I do the log of 1 divided by the log of e. That's how I would check that version of the answer, and that should equal to 0. To To check this version of the answer, I just type the ln button and hit 1 and find out that I have a true statement. Whether you put this version or this version, both of these simplify to 0, which is equal to the right side, so I know my answer is right. One more problem and then I'll start a part 2. So for problem 10, to write this in its logarithmic form, I write the word log, I leave some room and put an equal sign. The base of my log has to be this e. The 2 is going to move to the right-hand side and become on the same level as the log. The 7.39 is going to become the argument. And again, this would be considered an okay answer. Anytime I see log base e, I can write a better answer. Log base e can always be replaced with the ln. So a better answer would say the ln of 7.39 equals to 2. I won't do this on my calculator because this is an approximated answer. E squared isn't exactly 7.39. E squared is actually 7.3890560099. So if I tried to check this on my calculator, it wouldn't check exactly because this is a rounded approximation. So hopefully you can finish up 7, 9, and 11 on this sheet, and then we can move into the second part of this video, which I think there's only 2 parts to this section. So there might be a hiccup in the video. The video started getting really wavy, so I decided to cut and paste and fix the end of the video. There might be some waves at the beginning of the video, but I didn't think they were too offensive. So problems 12 through 26 give us logarithmic equations that are true, and we're supposed to write an equation that doesn't have a logarithm, that has the same numbers in the problem, and that equation is supposed to have an exponent, and it's supposed to still be true. Just real quickly to show you that problem 12 is a true statement, I can do problem 12 on my calculator using the change of base formula. On my calculator, to verify that problem 12 is correct, I can do log of 8 divided by log of 2, and that's what the logarithm on the left side is going to equal, and it equals to 3. So that in fact is a correct statement. The original problem in problem 12 really says 3 equal to 3. Now I'm going to use the formula, if log base b of x equals to y, then b to the y equals to x, by just identifying the b, the x, and the y. The b is the base, so in this problem the b is going to be the 2. The argument is the x, so in this problem the x is going to be the 8. And the number to the right of the equal sign is the y, so in this problem the y is going to be equal to 3. I'm going to take these 3 numbers and plug them into the formula. So the first number I'm going to write is b, which is 2. The second number I'm going to write is the exponent, which is going to be the y, which is going to be 3. And the last number I'm going to write to the right of the equal sign is the x, which is 8. This is also a true statement because if you did 2 up arrow 3, if you didn't already know it, both sides of this are 8. So I took an equation that started off saying 3 equal to 3 that had a logarithm in it. I created an equation has an equal sign. Exponential form implies you have an exponent that with those same 3 numbers, 2, 3, and 8 is true. That's the slow way to do this. If I do all these problems the slow way, it's fine, but it's not really the best way to do it. Let me do one more the slow way, then I'll teach you the way that you should probably know. And at some point, when I start doing the problems using the way that I know, which is kind of a shortcut, I even kind of don't even think about this rule. So if I was doing the same thing for problem 14 apparently says 4 equal to 4. If I did the change of base formula and did log of 16 divided by log of 2 to simplify the right-hand side, I'd get 4 equal to 4. So that's a true statement. The initial statement has the logarithmic equation that says 4 equal to 4. In this equation, the base is a 2, so the b is 2. The argument is 16, so the x is 16. And the number to the right of the equal sign is 4, so the y is equal to 4. I'm going to take those 3 numbers and plug them into that formula. So in for the b, I'm going to write 2. In for the y, which is the exponent, I'm going to write 4. I'm going to write my equal sign. And then I'm going to write the x, and then for the x I'm going to write 16. This is the answer for problem 14, and I can show you that it's true. If you didn't know that for sure, you can go 2 up arrow 4 and both sides of this equation are 16. This is a logarithmic equation. These are exponential equations. Logarithmic equations have logarithms. Exponential equations have exponents. Both of them have equal signs because they're equations. So that's the inefficient way to do this. The most efficient way to do this is to do this in steps. So if I was going to do problem 16, I can use this rule to do all these problems. If that's all you ever want to do, that's all you have to do. The way we generally do this, to write an exponential equation, we cross out the log, we leave the base on the left side, and switch the other two numbers. First of all, I should show you that that's true. That equation, if I do a change of base on my calculator, do log of 1 divided by log of 5, this equation says 0 equals to 0. It's a true statement with those numbers. Now I'm going to write an exponential equation. My answer is going to be real easy to get. I'm going to cross out the log. I'm going to leave the 5 on the left-hand side. I'm going to leave the equal sign between them. And I'm going to switch. The 0 is going to move to the left-hand side. The 1's going to move to the right-hand side. When I move the 1 to the right-hand side, it's kind of working like the 8 and the 16 in these problems, so it's going to be at the same level as the 2. When I move the 0 to the left-hand side, it's going to work as the exponent. I'm creating a problem, an equation with an exponent, and I have the base and the number to the right of the equal sign. The number to the right of the equal sign, when it moves to the left, becomes the exponent. That should be my answer to 16. I can show you that that's true. On my calculator, I can go 5 up arrow 0 for the left-hand side, and it shows me that that equals to 1. So I know that I've done this properly. The next couple problems, because they have x's, I can't check on my calculator, but I can still unwrap them. To write 18 as an exponential function, I'm going to cross out the log. I'm going to leave the 3 on the left-hand side. I'm going to leave the equal sign between. I'm going to move the x over to the right-hand side. I'm going to move the 2 over to the left-hand side. When I move the x over to the right-hand side, it's at now the same level as the 3. I'm creating an equation that has an exponent, so the 2 needs to become the exponent. This is a perfectly good answer. This is the answer that I'd probably have in my key for problem 18, but you certainly could write 9 equals to x if it bugged you that you didn't change the 3 squared to a 9. That would be okay. But for each of these problems, I didn't say that this reduces to 8 equal to 8, or this reduces to 16 equal to 16, or this reduces to 1 equal to 1. I just left the problem, the exponent, intact and didn't get rid of it. And so that's probably what I would do here. Problems 19 and 20 are written in shorthand notation because I don't see the base. If I see the word log and I don't see the base, there's an implied base of 10. So either I have to rewrite the problem or think of the problem with that base. And now that I have the problem written so I can see the base, I'm going to cross out the logarithm. The 10's going to stay on the left-hand side. The equal sign's going to stay where it's at. The x is going to move to the right-hand side. The 4 is going to move to the left-hand side. The 4 is going to become an exponent because the left-hand side needs an exponent. The x is going to be on the same level as the 10. And that would be my answer to problem 20. And again, you could write that as 10,000 equal to x if you care to. Your problem 19 has the same trick. For 22 and 21, I need to know that ln is shorthand for log base e. So anytime I see ln, I can replace it with log base e. For whatever reason, I decided to put these x's in a parentheses. My calculator always needs the argument of a logarithm in a parentheses. I generally don't put the argument of a logarithm in a parentheses until it's more complex, until the logarithm has maybe an addition or subtraction sign in it. I'll kind of dispense with the parentheses. So I needed to rewrite 22 just like I needed to rewrite 20 so that I could do the crossing and switching and know what to leave on the left-hand side. So now that I have it written in its equivalent but longer form, I'm going to cross out the logarithm. The e is going to stay on the left-hand side. The equal sign is going to stay where it's at. The 0 is going to move, and the x is going to move. When the x moves, it gets to the same level as the e, and it doesn't need to be in a parentheses. When the 0 moves, on the left-hand side, I need an exponent. I already have the base, so that's forced to be the exponent. If you wanted to, you could write 1 equal to x, but e to the 0 equal to x is just fine. Kind of getting overkill on these problems, but we'll keep going here. For problem 24, says the ln of e equal to 1. Let me show you on my calculator that that's actually true, because you need to get good using your calculator with logarithms. So this is shorthand notation. I do the ln button, and then second and divide for the e just by itself, close out my parentheses, and this is going to give me 1. So I have the statement 1 equal to 1. Let me rewrite this so I can get it ready to put in logarithmic form. I'm going to write this as the log base e, because ln is log base e, of e equals to 1. Now I'm going to cross out the logarithm. This e is going to stay on the left-hand side. The equal sign is going to stay where it's at. The e and the 1 are going to switch positions. The 1 is going to become an exponent because the left side needs an exponent. I don't have an exponent yet. The e, when it moves to the right-hand side, doesn't need a parentheses anymore. This says e to the first equals e. There's an implied exponent of 1 there, or this is actually just equal to e. Anything to the first power is itself. Let me do 26 on my calculator to show you that it's true. On my calculator to do 26, I type the ln button. And the easiest way to enter e cubed is not to use the e on the divide, it's to use the e with the exponent on the ln. So to do e cubed, I'd hit the second button and then the ln key. Now I can type a 3. My calculator gave me a parentheses when I typed the ln button, a left parentheses. It gave me a left parentheses when I hit second and ln. I should probably do 2 right parentheses to balance out the 2 left parentheses. And when I hit enter, I've entered the left side of this function. It should give me the right side, which is 3. So the answer, this is a true statement. I didn't need to do that. I just wanted to get you used to your calculator. To do this problem, to write it without a logarithm, so each of the problems in this grouping, we're writing it in exponential form, or we're creating an exponential equation. To do that, we cross out the logarithm. I'm going to leave the e on the left-hand side, the equal sign where it's at. The e cubed is going to move to the right. The 3 is going to move to the left. I'm creating an exponential equation, so the 3 has to be an exponent. And the e cubed, when I moved it to the right, doesn't need to be in the parentheses anymore. And that's clearly a true statement that e cubed equals to e cubed. 27 through 56 are kind of written for students that do math really well in their head. If you can't follow what I'm doing, you can do all of these on your calculator. So when I go to do problem 28, I'm going to explain to you how to get the answer without a calculator. But if I was doing 28, I could also do it on my calculator. If it was a test question and you're not comfortable doing logarithms in your head, then use your calculator. On my calculator to do problem 28, I would enter log of 1 divided by log of 2. My calculator is going to give me 0. If I have to write anything down to get the answer to a logarithm, then I should use my calculator. When I look at problem 28, what I think in my head is this is asking the question, the base 2 to what power equals 1? And I know that anything to the 0 power is 1, so I know that the answer to this is 0. If I couldn't just look at this problem and say, oh, that's asking me 2 to what power is 1, and I know that 2 to the 0 power is 1, if I couldn't look at that and know the answer and write the answer down without doing anything, I would never write that down, then I'd use my calculator. And on my calculator to do 28, I can just do log of 1 divided by log of 2. And it's going to give me the same answer. So I don't particularly care if you can't do the logarithms in your head. Not every student can do logarithms in their head, and it's completely okay if you can't. So, like if I was doing 30, I'd just write down 1 and not do anything. 30 is asking the question, the base 3, I'll use a question mark instead of what power, equals the argument 3. So the 3, the base, to what power is the argument? Anything to the first power is itself, so the answer to that is 1. If I didn't know the answer by just looking at it, without even writing that down, I'd break out my calculator and do log of 3 divided by log of 3. It's always log of argument divided by log of base. That has to equal 1 because you're dividing two identical things. 32 is asking the question, the base 3 to what power is 9? The answer to that is going to be 2 because 3 squared is 9. So the answer to 32 is 2. Again, on your calculator, you could just go log of 9 divided by log of 3. I'll never know if that's all you do because when I write down an answer to a logarithm, I just write the answer down. I think in my head what it's asking me, and I answer the question without writing down what it's physically asking. So give 29 and 31 a go if you haven't already. (34) is asking the question, 4 to what power is 4? The answer is 1 because 4 to the first power is 4. On my calculator to do that, I do log of 4 divided by log of 4, and you'd get that answer of 1. I'll do 35 instead of 36. 35 is asking 4 to what power is 64? If you know your powers of 4 well enough, you know the answer to 64 is 3 because 4 cubed is 64. Again, on your calculator, you could just do log of 64 divided by log of 4 and get that same answer of 3. I overkilled these. You can do 37, I'll do 38. 38 is asking 5 to what power is 125? I know my powers of 5 well enough to know that 5 cubed is 125, so the answer to 38 is just the number 3. Again, I can do log of 125 divided by the log of 5. And my calculator will know that it's also equal to 3. The problems on this page are all base 10. They're much easier to do on my calculator. I can do all 4 of these on my calculator without doing the change of base formula. To do 39, because it's in base 10, I can just type log of 1, and it's going to tell me that this answer is 0. For 40, I can do log of 10 without doing the change of base formula because the base is 10 and my calculator works in base 10, and that would be 1. For 41, I could do log of 100 and get 2. For each one of these, if I'm doing it by hand, I have to think of problem 40 as the log base 10 of 10. If no base is written and the word log is written, the base is implied to be 10. The question that's being asked in problem 40 is the base 10 to what power is the argument 10? And because anything to the first power is itself, the answer is 1. 42 is asking 2 to what power equals 32, and I know that 2 to the 5th power is 32, but I could have just done log of 32 divided by log of 2 and got exactly the same answer as 5 that I knew. Wow, there's like 2 more pages of these, 3 more pages of these. I'll just go through them quickly then. I'm assuming you can do them on your calculator. I'll talk through how to do each one in my head. 44 is asking 3 to what power is 243? And I think 3 to the 5th power is 243, so I think the answer is 5. If I did log of 243 divided by the log of 3, still get that same number 5. 46 is asking 3 to what power equals the argument of 3 to the 4th. It's the base to what power equals the argument. And 3 to the 4th equals 3 to the 4th, so the answer to 46 is going to be 4. If you wanted to do that on your calculator, you'd go log of 3, up arrow 4, close out the parentheses for the log of the argument, and then divide it by the log of the base, which is going to be the log of 3. And that's going to come back with this 4 that you can't really see. 48, the base is 7. Logarithms ask the base to what power is the argument. The argument is 7 to the 8th. To make this equation equal, that question mark has to be an 8, so the answer to 48 is 8. On my calculator, I'd go log of parentheses 7 up arrow 8 divided by log of 7. And, whoa, what did I do wrong? On my calculator, I do log of 7 up arrow 8, close my parentheses, divided by log of 7. And I get 8. I don't know what I did wrong when I cleared it, but I did something wrong. Ay, ay, ay. Problem 50, let me just do it on my calculator. Log of 2 up arrow 9 divided by log of 2. It's going to be 9. So if you didn't know the answer was 9 by just kind of glancing at it, use your calculator. The next problems I can do on my calculator just fine because they're ln. If you wanted to do 51 on your calculator, it's so hard to find a place for this. You'd hit the ln button, which is down here, and then I'm trying to find the ln of e, so that I just hit second and divide for an e without an exponent. The answer to 51 is going to be 1. To do my 52, I'd hit second, first I'd hit the ln, and then second and ln to get an e with an exponent, and then I type 2 for my exponent. My calculator forced 2 left parentheses. I'll close those 2 left parentheses with 2 right parentheses and get an answer of 2. The answer to 51 was 1. The answer to 52 was 2. The answer to 53 is going to be 3. To do 51 or 2 in my head, I have to think of the ln as the log base e. So I think of this problem as the log base e of e squared. And this is going to ask the question, the base is e. To what power is the argument e squared? The reason my calculator came back with a 2 is because e squared is equal to e squared. So you should be able to do 55 on your calculator or in your head. For 51, I'm going to do this by hand. 51, I think of this as a log base e of 1. ln and log base e are interchangeable. This is asking me the base e to what power is 1. I know that anything to the 0 power is 1, so this must be equal to 0. On my calculator, if I just did ln of 1, it would tell me that the ln of 1 is 0. 56, if I did it by hand, I'd have to think of this as a log base e of e to the negative 3, which asks the question, the base e to what power is the argument e to the negative 3? For these two to be equal, the exponent on the left has to be negative 3. On my calculator, I can just enter that more or less like it looks. Hit the ln button, and then second, and then the ln button again for the e, and then negative 3, close 2 parentheses, and it'll give me that answer of negative 3. So you should be able to do 55. The rest of this section is just using our calculator and rounding to 4 decimals. The rounding might be the hard part.